If you're watching this video, it would be useful if you watch parts 1 to 3 beforehand. This is an example of a question involving geometric series. And the question is as follows. A geometric series has the following properties. The first and the second terms have a sum of -4. And the fourth and the fifth terms have a sum of 108. Find the first term and the common ratio of the series. Explain why the series has no sum to infinity. So, let's convert that information into useful mathematical statements. The first term and the second term add up to -4. The first term is A. The second term is A times by R. And they add up to -4. That's a useful mathematical statement. The fourth term, that is AR cubed. Remember, if it's a fourth term, there'll be 4 take away 1 here. That's where the 3 comes from. And the fifth term, that's AR to the power of 4. And we're told they add together to give 108. I'm going to call that line equation 1, that line equation 2. And what I've got here actually are a pair of simultaneous equations. The first equation, I could take A out as a factor, and I can rewrite it as A into 1 plus R equals -4. So I've just taken that A out as a factor. In equation 2, I can also take A out as a factor. In fact, I can take more than that. I can take AR cubed out as a factor. And then I can multiply my AR cubed by 1 to get AR cubed, and my AR cubed by another R to get AR to the power of 4. So I've taken a common factor out of both of them, or a factor rather, out of both of them. And now, using something I did, I think, in the previous video, I can do a divide. If I call this equation 1a and this equation 2a, they're just different versions of equation 1 and equation 2. Choose the one with the highest power of r in, which is this one here, and I'm going to do equation 2a divided by equation 1a. So I'm going to write that out. Equation 2a, which is ar cubed 1 minus r equals 108. And I'm going to divide that on both the left and the right hand side of the equal sign by equation 1a. And 1a is a into 1 minus r equals -4. And now I'm going to work with what I've got here. And because I'm doing a dividing here, I can do some cancelling. And the 1 minus r on the top in a bracket will cancel with the 1 minus r on the bottom in the bracket. So I can strike those through, cancel them out. And also the a on the top and the bottom, I can cancel those as well. So on the left, I'm actually just left with r cubed. And on the right, I'm left with 108 divided by -4. And 108 divided by -4 is -27. So I've got r cubed, no a involved now, r cubed is -27. To get from r cubed to r, I need to cube root. And if you're looking for a cube root button on a calculator, they'll probably have the root sign with a small 3 there. And if you look on the calculator I'm using, we get the cube root button here. It's in brown above the square root button. So on this calculator, I will need to use the shift button as well. So on this calculator, I will do shift and the button we've just mentioned. See if we can see that a bit better. I'll put the 27 inside the cube root, except it should have been -27, so I'll put the -27 inside the cube root, and then do equals, and I get -3. So the cube root of -27 was -3, so that's my value for r. Now the question said I had to find u1 and r. Well, I found r, so finding u1, well, remember u1 is the same as a. So that's what I've got to find now. And if I go for my equation 1 up here, which is the simplest of my set of equations, equation 1 was a plus ar equals -4. Well, I now know that r is -3. So I can rewrite this as a plus a times by -3 equals minus 4. The usual way of writing that would be a minus 3a equals minus 4. So if I have 1a, take away 3a, effectively I've got minus 2a equals minus 4. And if I divide both sides of this by minus 2, the minus 2 disappears on the left, and minus 4 divided by minus 2 is 2. So I now have a. So I have a is 2, I have r is minus 3. And the last part of the question was, why is there no sum to infinity? And if you look back to a previous video in this series, you could only sum to infinity using the formula a over 1 minus r if r was between 1 and minus 1. In other words, if r was plus or minus 0 point something. And that's why there's no sum to infinity here. You can only sum to infinity if r is between minus 1 and 1. And our r was minus 3, which is outside of that range. That's why there's no sum to infinity for this question.